Dr. Pekka Manninen is the director of this leadership computing facility, LUMI. It's a large, one of the main consortia of Euro HPC program. I need to mention that Poland is part of this consortia, so we are very, very interested in Poland to learn about what's happening there, what is this facility. Say more about Pekka. Pekka has a long experience in HPC and HPC infrastructures and has been involved in several pan-European infrastructure initiatives over the course of years. He holds PhD in theoretical physics and is an adjunct professor at the University of Helsinki. Pekka, the floor is yours. Welcome.
Thank you, and good afternoon from a very hot and sunny Helsinki. So my pleasure is today to introduce you to the one of the Euro HPC pre-exascale systems, and this is the well, the northern one, and hence the bit icy pictures there. So in the next couple of minutes, I will walk you through to LUMI. And LUMI is an kind of like a first of its kind of an endeavor. So it's a supercomputer system being hosted in Kajaani, Finland, in a central part of Finland. But it's not the Finnish system, but it's a joint effort of 10 European countries seen on the map, Poland included, as just said, and European Commission. And with then kind of like a first of its kind endeavor of jointly invest in, jointly operate, and do decisions together in a consortium governance for the system. And the system is in Finland, but the consortium could have chosen to locate it in some other of these countries, but there were reasons for putting it to Kajaani. And LUMI system will be operated such that each of these consortium countries will get share of the computing resources according to the investment to the total cost of ownership. And of 1/2 of the TCO is covered by the Euro HPC JU, and hence 1/2 of the resources is available for European researchers on any of the countries that are part of the joint undertaking. And the rest, remaining 1/2, is then for the consortium countries to allocate as they see it best. And like I said, there was a clear reason why we chose to put the system to Kajaani. And first and foremost, it's just we have the facility there to put it. And it's a former paper mill, paper machine, demolished paper production gone to Latin America over 10 years ago, but the site and the capabilities remain. And as a remnant of the paper production, there is plenty of power to the site, so we could host supercomputers all the way to 200 megawatts. LUMI is 10-ish megawatts, so we will have plenty of space more left. But this is just like an idea that at least we won't be running out of green power anytime soon. Also, the paper machines couldn't be down for a moment, so hence the electricity is there as a local supply and in a part of a national grid. So the whole site has had one electric blackout in the last 40 years. And this is a pretty high up in north, so we can do free cooling throughout the year, rendering to a very high or very good power usage efficiency of the system. But in fact, this time we are not using free cooling, but collecting the heat and heating the surrounding city of Kajaani. And in fact, of the city is being heated up by the excess heat of LUMI. And this is we can really sell this heat, and rendering the energy price to a very competitive price, probably the lowest in whole Europe. And these are the reasons that I mentioned why the consortium decided to use Kajaani as the site for LUMI. And it's maybe remote on a map, but it's very well connected site. And as a robust industrial site, gives very high security standards for hosting the system. But the system itself, it is going to be, like I said, title indicates the flagship system in Europe. So it will be the fastest in Europe for quite some time after the start of the operations, with peak performance over 1 exaflop. So, and committed leanback is 375 petaflops. It is going to be an HPE system with the brand of Gray that HPE purchased some time ago, and computing power equivalent to 1.5 million laptops. Of course, we won't need such a tower of laptops, but I can in fact pack it to the quite compact footprint. And more importantly than the big flops and things are the what is enables, and it's going to be this kind of a very modern design for the convergence of HPC, AI, and high performance data analytics. And in terms of the composition of the machine, you can see very much similarities to the Meluxina machine here. I'm just calling them partitions and not modules, and on purpose. And in a similar fashion as Meluxina, LUMI is featuring different partitions, with most of the computing number crunching power racing from the GPU partitions based on AMD GPUs, also complemented with supplementary CPU partition, data analytics partition, some cloud resources for running microservices. Everything happily sitting in the same interconnect and seeing the same user environment and storage systems. Also, the storage is tiered to 3 tiers, so with a big flash pool to combined with a large, more traditional parallel file system, and a object storage service for data management purposes. The one thing we are very proud and keen and having and very much focus on is the user experience. So it may not be the number one in top 500, but we have a clear target of being number one in the user experience. So it's consisting of or the efforts for that reason towards that goal is consists of having an ambitious user support layer there between as the kind of a frontline support, with plenty of resources throughout the consortium for supporting this support team. So I think that we will have a very nice pool and share model for competencies of these 10 consortium countries, because this support team is not based at CSC, but spread over the whole consortium. We have a couple of initiatives that we are working on at the moment for for enhancing the experience. So we are looking at alternative user interfaces to command line interface based on more graphical interfaces like notebooks and things. We are devising the software portfolio of the ISV software. We are working on something called a concept of datasets as a service, meaning in addition to pre-installed software, there are like a pre-installed curated datasets available on the system. And also we are working on methods how could we support sensitive data on the system. These are something that we are working on. They are on best effort, but are not especially the latter is something that I cannot give any guarantees on the schedule of that one. The timeline is so that the data center, looking this kind of a snowbank in the one of the paper machine halls, is ready to take a system, and this system is currently being installed. So the physical installations have been done. So the first phase racks are on the floor, working currently on the integration part, starting the handover for the testing period very soon, so that we can open the first phase for pilot users after the summer break. And the first phase is consisting of the CPU partition, storages, and the early access platform that is an porting platform for the GPU applications for the main thing, which is the our second phase, where the GPU partition comes in towards the end of the year. And LUMI will be listed on top 500 in the November list this year. About the applications that we envisage, well, first and foremost, we have designed LUMI as it wants to be this kind of a Swiss Army knife, so there's some kind of a tool for the workloads encountered in this decade in scientific computing. But just dropping some use cases and codes that we think LUMI will be in the beginning very useful include the digital twin of the Earth, known as the Destination Earth project. So we help to LUMI to play a major role there on the climate adaptation modeling. We think it's going to be one of the leading platforms in data science, especially machine learning. We are looking forward to also to help the traditional simulation science, like encountered in plasma physics or molecular dynamics, to be a really powerful engine for that. And why not also material science and quantum chemistry. And also we are hoping to reach out to the new user communities to find that I'll say digital humanities, social sciences would find this leadership scale supercomputers a new tool for furthering their research. And the final remarks I have in mind is that how can I prepare for the upcoming system? Like I said, we are entering the pilot testing period now, and the beta testing now towards the end of the year, with the system being available at the beginning or on the first quarter of next year. So all users in Poland and elsewhere in Europe, I think it's a very high time of thinking the big projects and use cases for LUMI where we could provide a new capabilities for you. LUMI is a GPU system, so a GPU-enabled codes will be needed. But of course, there's a vast pool of the community codes already, and so it's time to investigate whether some software effort is being needed. Highly likely, yes. But modernizing software is never a bad idea. So even if it works, it's a very good idea every now and then to fix the software still. Yeah, so with this, I would like to welcome everybody to the Euro-HPC era. So the Euro-HPC joint undertaking is bringing an unprecedented amount of computational resources and services and capabilities for European research and innovation. So not only the world-class infrastructure, but also complementary competence building support activities. Well, it is LUMI in up north, and with an design of an broad range of user communities, workloads, and the user experience in focus. It's a GPU system, so not out of the box for all software, but it's a robust production system, not experimental or esoteric in any manner. And for harnessing this or any other of these big Euro-HPC systems, software modernization efforts will be needed. And like I said, it's not trivial niche effort, but it definitely will pay off. So with this, I would like to see if there's any questions, and please do visit the LUMI supercomputer.eu website, contact us, follow us on social media, or approach us in case of any questions. So with this, I thank you for your attention.
Thank you very much, Pekka. Hello, I'm not sure if you can. Yes. Thank you very much for this very interesting report from LUMI. And as everybody sees now, and then we'll witness it by listening to following lectures, there is tremendous accelerated effort in Europe to build the European infrastructure, to provide the best computing facilities for European scientists. And as we have seen in Pekka's list of applications, they actually are convergent with many of these global issues, like health, climate change, social structure and processes, and many more, materials, energy. So we see those fantastic facilities being applied to the best and most important weighty projects. I don't see, so our audience is just getting used to the platform perhaps, so I don't see the questions from the audience, but maybe I will ask Pekka a question. How much effort is needed to really accelerate some of these applications? I'm aware of incredible achievements of Swiss groups from a Swiss National Supercomputing Center in accelerating a Cosmo model using the best principles of software engineering. Could you give a few more examples of that kind of work being done?
Yeah, I think it is a kind of what the heroic undertaking when you take this kind of a very old established better code and make it an accelerated version that also NWP people will accept of their kind of how accurate they want things to be. So that's kind of one extreme. Of course, on the other one, we have just like in a lab applications where it's sometimes tens of thousands of lines of code, and there the porting efforts can be in fact quite limited. So it's very important for modernization. So that, well, dependent. It's hard to give kind of a very straightforward answer on this one. So you think ranging for several FTEs, that like the Cosmo effort, to something that you can do in a how do we develop scientific software on different labs and research groups. But the kind of a key ingredients here is that people really think about in terms of modernization. So abstraction, using high-level libraries, using frameworks, being able, just like having the kind of willingness, readiness to invest and redesign on the applications. So, and I cannot give a very straightforward answer on this one, but something is like I said, it's non-trivial, but it's definitely an investment that will pay off in the future.
Okay, we have two more questions, and we should have enough time to for them. One is from Jarosław Skomiał. Could you please shortly describe the design process of LUMI? Who did it? How many people were involved? How much time it consumed, etc.
So there were quite many people on the consortium. So it was a kind of interactive process of a series of workshops that we did from the LUMI Consortium. So the 10-country or 9-country back then consortium of people sent over the CTO style enrolled people. Then we spent some time in TSC to work on the vision, and then it distilled to the RFP of the system when we run the procurement, and then the outcome of the system is, of course, a tender to that RFP. So that was also a collective effort of the consortium.
Right. So we have two more questions, or was it one from Clem Lau? Is it assumed that LUMI users will have ported their codes or modernized their codes before running on LUMI, or are there people at LUMI available to help?
Definitely, the user support team is there for consult. The user support team can consult you and help you out there. We can provide now already the early access platform, or not now, but in a few weeks, an early access platform for you where you can start working on the codes that will be basically the same architecture as LUMI GPU partition is. So, but definitely there's many forms of help available for the code porting efforts.
Okay, Pekka, thank you very much. We have to rush to the next talk. Thank you very much. That was very fascinating. It's so great to see such an incredible facility and expertise being built in Finland. And us in Poland, being part of it, it's a great company to be with and be associated with. So thank you very much.